All right, kids. We're going to basically the cool thing about lesson 6 here is that it's basically the same as the last lesson. So we're going to give more practice with that. We're just going to kind of do the same thing, but in a new context. In this video, all we're going to be looking at is finding the least common denominator. Now, if you know what that word denominator means, then you probably can be clued in that you're going to be thinking about fractions, right? But we're not going to do much with them in this lesson. All we're going to do is find a common denominator, the least one, right? Because we learned about least common multiple in the last lesson. We use the same idea to find the least common denominator. So, and we're just gonna add kind of one more little piece, one more tiny piece to it, okay? So, and it goes with what I said at the end of last lesson. Okay, so let's jump in with an example. We're gonna do example number 1. I'm gonna go ahead and write big because why not? It's middle school A. All right. Okay, so example number 1. So let's find the least common denominator between 1/2 and 3/4. And then we're going to make them be the same thing. So we're looking at just the denominator. Now the denominator is the bottom part. Excuse me. So the first thing we're going to do is we're going to find the least common multiple between these denominators. So between 2 and between 4. So we start here and list our least common multiples. Oh, look, we're done. Oops. Except I probably should have put 2 and then 4, and then this one would be 4, right? So we found it. Now, what we need to look at, so 4 is the least common denominator. So we're going to end up forcing both of these fractions to have a denominator of 4, okay? And we'll look at kind of what this means here in just a second. Excuse me. Sorry. And as far as kind of our pi piece fractions and equivalent fractions and all of those kinds of things, okay? So what we need to do now I talked about this before. We want to figure out what times 2 equals 4. So that's kind of where we're gonna go next on this piece. So 2 times what equals 4, and then, and then 4, so our other denominator, times what equals 4. So what would go in this box? Well, 2 times 2 is 4, easy peasy, and 4 times 1 is 4. Now, to make them the same, this is what we have to do. Now, and I'm going to show you why this works for those of you who are why askers. If you're not a why asker, then just do what I tell you to do and don't stress about it. Hey, the reason why we can do this is if we have any number, so like 5, over itself or divided by itself. What's 5 divided by 5? It's 1. We can do the same thing with 6. That's also 1. We can do it. I'm going to sneak in a letter here. We can do it with any number. Any number over itself equals 1, right? And so we can do that. Now, also, the other reason why we can do what we're about to do is this little box of things. If we take 6 times 1, what does that equal? 6 times 1 equals 6, right? What does 8 times 1 equal? Well, it equals 8. So, again, if we take any letter, let's use A this time. Why not? Any letter, any number, actually, any number, and multiply it times 1, it stays the same number, okay? So this is the why of what we're about to do. We'll also take a look at it with kind of our equivalent fractions and those kind of things. And so what we're going to do is we're going to use our second color for this. We're going to, next to each one, we haven't really learned that yet. we're going to learn something else new. It dawns on me that we haven't learned what I was about to write. So let me in this particular class, we have in other classes, but we know that this means times, right? There are two other ways. We're going to talk about one of them. Two other major ways to write times. And the one that we're going to learn now is if we have parentheses right next to with nothing in between it. See, there's nothing there. Nothing there. Nothing. Right? If there's nothing there, then two sets of parentheses right next to each other would be multiplication. So, like if we use this as an example and we put 5 times 3, that would equal 15, right? So if we have parentheses right next to each other, that means times as well. I'm gonna leave this on the screen for reference, but I'm gonna move it out of the way. We're getting a little bit crazy. I'll make a new screen as soon as this first example is through. Okay, so let's get my stuff back. All right, so we're going to open up a set of print. Oh, we're going to open up a set of print. I can speak. Don't say I can't speak. I can speak. I can speak great, grand, and gloriously. The other piece of this puzzle is that if you have a number like 6 with a parentheses next to it, that also means multiplication. So those are some different ways to write multiplication that we're learning for the first time today. There's one more that's going to be really common soon, but that we'll use a lot, but we're going to see this one as well. Okay, so we're going to put parentheses. Now, inside the parentheses, we're going to put a fraction. We're going to do this on both of them. We don't technically have to do it on this one, but we're going to do it anyway, just to stay in the practice and to see what's happening. Okay, so what we have to do is we have to put this number. So 2 times 2 equals 4. So we got to put that number in here, and we got to put it on the top and the bottom, because now that equals 1, and that's why it's allowed, right? And then for this one, we've got to put this number. So we're going to put 1 in there. Okay. So 2 times 2 is 2. And 2 times 2 is 2 times 1 is 2. 2 times 2 is 4. Right? So that one, and then 3 times 1 is 3. And 4 times 1 is 4. Okay, so now they have the same denominator, and that's what we're going for. So see, we're using the same least common multiple, and we're just shoving it into a fraction by multiplying. We'll do a cleaner example without all this extra explanation next, and that ought to, if you're a little confused, I think that'll probably help, and we'll do a couple more as well after that. So let's take a look at some examples. Must be getting allergies or something. My eyes are all itchy. See, anything else we need to talk about on this example before we move? Oh, I do want to. So what we've just done here is we've turned 1/2 into 2/4. So we're talking a little bit about equivalent fractions there. So if we have, let's pretend like that's a circle, and let's pretend like that's a circle, and let's pretend like they're the same size. Okay, so we had two different fractions here. We had 1/2 and 2/4. Right? If we're going to draw those as kind of a circle fraction diagram, 1/2 would be something kind of like this, where we have it divided into 2 and one of them shaded. 2/4, we would have something like this, where we have it split into 4ths and then 2 of those shaded. What do you notice about these two circles with the shaded parts? Well, they're the same, right? So 1/2 equals 2/4. And that's what we're doing there. We're turning these two fractions into having the same denominator in order to do other stuff with them. For one thing, we can compare them. Which one's bigger now? Which it's harder to compare if they don't have the same denominator. Now looking at this, well, 3's bigger than 2. Yay. Maybe that might be part of the next lesson. Maybe. Well, maybe a lesson or two down the road because we're going to shove some decimals in there too. But we got this. All right? So let's do example 2. Example 2. Let's do 5 sevenths. Whoops. And let's say 1/4. So we're going to make these have the same denominator. So again, we're going to do the same idea. We're going to start out by finding the least common multiple between the two denominators, 4 and 7. So the multiples of 4 are 4, 8, 12, 16, 18. Let's check our 7s and see where we go from there. 7s are 7, 14, 21, 28. Well, 28 is 7 times 4, and we're not quite there with that. Nothing else matches. So I bet that's where we're gonna go. What do y'all think? I'm gonna bring my 4s down to this next line here. I think that's gonna be reasonable. What do y'all think? Is it phenomenal? 4, 8, 12, 16. Oh, that's not a multiple. 18's not a multiple of 4. Did y'all catch that before I did? Are y'all so super brilliant? I tend to do that at that point. I don't know why I shift into 2s when I'm counting by 4s. So how about 20 and then 24 and then 28. So the smallest one that matches is that one. Now this actually teaches us kind of another way to do something we're going to learn later. We'll get there. We'll get there when we get there. But for now, we're just trying to find the smallest common denominator. So we're gonna walk through our puzzle pieces here. So 4 times what? Actually, so we can practice. 4 times what? I think that's a good idea. What do y'all think? 4 times what equals 28? And 7 times what equals 28? And then we fill this in. We're going to put a 7 right here because 4 times 7 is 28. And we're going to put a 4 right there because 7 times 4 is 28, right? There we go. So we're going to do just like what we did before. We're going to do a big old parenthesis right here. And a big old parenthesis right here. Now this time, it's not going to be 1 on one of them. It's going to be, for this one, we want to put 4s. See, we're putting for the 7 one, we're putting this number. 1 in the box, right? And for the 4, we're going to put the 1 in its box. So we're going to put 7 up here. And then we've got to multiply on the top and on the bottom because that's how we multiply fractions. We may or may not have seen that. We're going to practice a lot of it with reducing and all kinds of cool stuff later. But for now, we're just going to multiply. When you multiply, in case you have not seen multiplication, I didn't really explain this on the first example. I kind of worked the assumption that you have multiplied fraction before. But if you've never multiplied fractions, you do it straight across. The numerator times the numerator, the denominator times the denominator. Okay? So if there was any confusion, I hope that clears it up. 5 times 4 is 20. And then 7 times 4 is 28. 1 times 7 is 7. And then 4 times 7 is 28. So which one's bigger? 5 sevenths is bigger because 20 is bigger than 7. All right, let's do one more example, and then I think we're going to be done. Times, yeah, we're doing pretty right on with our times. Let's do example 3. Let's do, how about, excuse me, 5 eighths. And how about let me pause. Pause. All right, sorry. Let's do 5/6. I hate that word still. I know I say it every time, but I just really do. It's a terrible word. Okay, so we want to find the least common multiple between 8 and 6. All right, so I like to start with the smaller one. You can do it. You can really do it either way. But let's start with 6. So 6, 12, 18, 24, 30. That's probably enough to start with, right? So 8, 16, 24. Oh, look, we found one that matches. So those match. So now let's make our boxes. We'll practice our new multiplication symbol, right? So 8 times what equals 24. So the one that's in common, right? And then 6 times what equals 24. All right, so what goes in the box? 8 times 3 equals 24. And then 6 times 4 equals 24. All right, so we're going to take these, and on the 8 fraction, we're going to put his box number. So we're going to put 3. And then on the 6, we're going to put his box number. So we're going to put 4. And then we got to multiply. So 5 times 3 is 15. 8 times 3 is, of course, 24. And then 5 times 4 is 20. 6 times 4 is 24. So that's where we're going to quit for now. We'll catch you on the next one where we learn more things with fractions and decimals and all kinds of cool numbers. Hope you're having a great day. If you're one of my students, I'll see you in class. Do your homeworks, all the things. If you're not one of my students, thanks for joining us. Everybody, don't forget to like, comment, and subscribe. Bye-bye.